Welcome to Air Academy Associates series in using SPC Excel. Today's topic will be the graphical analysis tool called a box plot. We will introduce the box plot by showing you some PowerPoint slides as to what it is, what are some of its key features, and then we'll give you a brief example, and then we'll jump right into the software to show you how it's done. This is really a straightforward tool. There are not a lot of options associated with it, and I think you'll find it very valuable. So what is a box plot? Well, it's another method for graphically displaying continuous data. It is especially useful when we want to compare two or more sets of data. And we do this side by side. That's what a box plot does. If we only have one set of continuous or variables data, we might use a histogram because there's nothing to compare it with, that is multiple data sets. But when you have two or more data sets, this is an ideal, very simple, but easy to understand tool to use. Now, the key characteristics or features of a box plot are, first of all, the box. The box that I'm referring to is right here. It's a rectangular box, and there are two whiskers on either side of the box, that is on the top of the box and also on the bottom of the box, where the maximum value is given at the top and the minimum value is given at the bottom, and the length of the box is called the interquartile range. That is where the middle 50% of the data falls. So what a box plot does, what the software does, is it sorts the data from smallest value to largest value. The median, also known as the 50th percentile, will get a little plus in the box. And the ends of the box are the 25th percentile and the 75th percentile, which are also called the first and third quartiles, respectively. They house the middle 50%, from 25th up to the 75th. So it's a sorted set of data. If the plus sign or the median is here, that means 50% of the data is above the median and 50% of the data is below the median. So because the distance from the median to, in this box plot, to the maximum value is greater than the median value is to the smallest data point, this data set would be, if we did a histogram on it, would be skewed to the right. The tail would be to the right. But nonetheless, let's take a look at what it looks like when we get a box plot. Let's suppose we're comparing two different laboratory times. Smaller is better. The unit of measure is in hours. We're looking at the cycle time for a lab to complete a special type of blood test. And we want to compare the two data sets. This is a typical application of a box plot. We sometimes have more than two groups of data, but in this case there are only two. To create the box plot in SPC Excel, we do as always, first highlight our data. See over here, we have two columns of data. Then we go to Analysis Diagrams, which is a main menu item in SPC Excel, and we come down to Box Plot. We click on Box Plot, and then it's going to say or ask you in a user interface box, where is your data? If you've already highlighted it, you can click right through. If you haven't highlighted it, this is the place where you highlight the data. Click on that, then highlight your data. When you're finished, you click Next. And this is a very important user interface menu. It asks you the orientation of your data. Typically, most of us deal with columns, but you could have two rows here of data also, where lab 1 is your first row, lab 2 is your second row. Typically, most people work in the columnar format, but it doesn't matter. You could also have one group of data, but if we had only one group of data, we would more than likely use a histogram to characterize that set of data. But in this case, our data is in columns, and you need to check that, and then you say Next. And what will come up is the box plot. It's very simple. How do we interpret this box plot? Which lab has the most variability? Well, clearly lab 2. the data expands from way down here all the way up here. You've got much more in the interquartile range. Over here, your variation in lab 1 is much, much less. It also has a smaller median. So the center point of this data set is actually a little smaller than the center point of that data set. So this is a very convenient way to take a look at comparing several data sets. So let's go to the software. So we've brought up a data file consisting of 5 columns. These are processing times at 5 different facilities. Smaller processing times are better. And we would like to compare the 5 facilities regarding their processing times. So, as always, we highlight the data. And you can highlight the label as well. If you don't have a label, it will use F, G, H, I, and J. That is the columnar headings for your 5 different data sets. But it's good to have a header like facility 1, 2, and so forth. So we've got that. We go to Sigma Zone. We go to Analysis Diagrams. And this time, we want to compare by way of a box plot. Click on Box Plot. Is this the data we want from F4 all the way to J19? It is. If you have not highlighted the data, click right here and do so, and then click on Next. And here is that critical menu where you don't want to say this is one group of data. We have 5 groups or data sets, and they happen to be in columns. And so we then click on Next, and here comes your box plot. So how do we interpret these 5 different data sets? We have 5 different facilities as annotated down here on the horizontal axis. Facility 1, 2, 3, 4, and 5. Which of these facilities seems to be different than the other ones? Well, it clearly is this guy. It's facility 3. They have a lot of variation, plus their center point is way up there at 53. Now, if you put your cursor on that little red cross or plus sign, you will see the value is 53. The value here is 37. The value here is 39, and so forth. So you can get these values right up here if you look at and put your cursor on the top X. Your maximum value was 69. Your minimum value was 41. And so you can use your cursor to kind of navigate to find specific values. But it's clear that the center points of all 4 facilities, 1, 2, 4, and 5, are pretty much the same. But this one is different. And that is the purpose of a box plot. There are not a whole lot of different features or options that one has. The box plot is pretty stable, pretty static. You have a box, the interquartile range, which is what the dark blue represents. There's your smallest value. There's the 25th percentile. There's the 75th percentile. Here's the 50th percentile. And up there is your maximum point. So it gives you a really good feel as to how these different data sets are behaving. So that completes our treatment of the graphical analysis tool called a box plot. It's very valuable when we want to compare 2 or more different data sets. Thank you very much.